Awesome. I will say a quick welcome. As mentioned, thank you, Ben. My name is Jesse Vadala. I work as an engagement manager for Trout Unlimited. Excited to partner with Kyle, who's a biologist working in our conservation staff here in New York, to walk you through some really exciting talk about not just collaboration, but also ways we've connected with our communities to do this work for cold water and beautiful wild fish like the brook trout you see on screen. So thank you for this opportunity to talk. And I'll play host here momentarily and introduce you to some more folks, and we'll kind of step through a little bit of the philosophy of who we are and start talking a little bit about Trout Unlimited. Again, as mentioned earlier, funding was provided by New York State Water Resources Institute and the Great Lakes Watershed Program in New York State Department of Environmental Conservation with support from New York State Environmental Protection Fund. So a little bit about Trout Unlimited. We started in 1959 as a group of folks all around the country who are interested in the recovery of trout. Declining numbers of trout created some really interesting strategies to help bring back the idea of more trout. Trout Unlimited, as an organization for people, individuals interested in rivers and cold water, get to benefit from this great development we found over time about how cold water can be cared for and wild trout can be cared for by people in the community. So citizen science really became the kind of defining backbone of who we are at Trout Unlimited. And we bring people together to take care of our rivers. So that's really the big high point of who we are. And when you hear Trout Unlimited, you should think about it as you yourself, someone who gets attached to a river and thinks about ways you'd help take care of it and all the beautiful creatures that benefit, like the brook trout, again, that you see here. So, a little bit about our mission and our vision on screen there for you, too. Quickly, before I dance through and let Kyle take over, I wanted to introduce you, at least by photo, to some of the folks that work here at Trout Unlimited and tell you a little bit about what we do. So the top left photo there, you see my smiling face and Jeremiah Stone and Tracy Brown. So a restoration manager for New York and Connecticut, that's Tracy Brown. And then Jeremiah Stone also being a stream restoration technician and coordinator in the field. Just off the side there, Jacob Fetterman working on the Battenkill watershed as well as the Saranac watershed, a project manager and coordinator with a lot of great experience helping recover rivers. John Braco and Jeremiah, a senior advisor, really understanding the way that rivers move. So, a really fascinating individual that helps guide our team. A couple of looks at some of our seasonal staff that have become part of our full-time team. So some of those individuals are on this screen. As you can see, Kyle there with a drone getting ready to fly and do some deployments for water temperatures. And Asia Rose, who's one of our full-time technicians, taking care of multiple watersheds across New York, and Joanne Humphreys, who designs and implements structures for aquatic improvement. So this is a little bit about our team, and you too can be a part of the team at TU. So we are hiring right this moment for positions all across the country. But even right here in New York, we're looking for seasonal employees to join us for 12 weeks down in the Upper Delaware in Hancock, New York. Really great seasonal position with lodging included. Really fun, get to learn an incredible watershed. The QR code you see on screen will take you straight to TU's website for all of our jobs and internship opportunities. I highly suggest you bookmark that page and check it. We post jobs frequently and they are awesome. So I'm thankful to have been working here at TU since 2002 or 2022. And it's been a really, really great couple of years here so far. So I wanted to pass the baton over to Kyle and let him run the show from here. And it's been a great opportunity to get to learn from him about some of these Western rivers that I've never even seen until this time. So take it away, Kyle.
Thank you, Jesse. Awesome intro as always. Hi, everybody. I'm Kyle Glenn. I'm the New York biologist and coordinator. So I focus a lot on our data, our implementation, and our monitoring strategies across the state. As Jesse referenced as well, there are job opportunities in the Upper Delaware for this season, and that was my first foot in the door as a full-time position at TU, and it was a fantastic experience. So I do not recommend it enough, and I hope people do not shy away from working in the Catskills. It is beautiful country over there. Speaking of beautiful country, though, we kind of have an untapped portion of New York State that we're just starting to sink our teeth into a little bit here from a conservation standpoint. And we're talking about the Western New York region. This photo here is on a Class A wild brook trout stream. Uh, we can see hundreds of volunteers throughout the years have helped work on these systems. However, it really hasn't gotten the notoriety compared to other areas across the state. And as we see here, streams really are the lifeblood, and collaboration is key. We work extensively with the Fish and Wildlife Service and DEC across multiple regions. Kind of stemming on to the collaboration, I really fell in love with this group of partners and collaborators, and part of it really comes from the idea of like communicating versus truly connecting with your partners on a human level. And that's exactly what we have done with Ryan Elliott and Emily Fell. They're both Great Lakes coordinators for the DEC, and they've really helped tremendously with support and leveraging in terms of funding in order to get any of these projects off the ground in the first place. So this WRI funding that we received, we've been able to now leverage it into other grants. So in total, for our work in the Adirondack regions, we have leveraged 2.7 million so far. And in the Western New York region, Genesee River, we've leveraged close to 500,000. So very, very thankful for all of Ryan and Emily's work. They do a ton of office work, outreach, and they're always willing to jump on a call or answer an email at the last minute. So a ton of appreciation, and also, their appreciation for the resource itself. I was lucky enough to be able to ride with Emily through the backcountry of the Adirondacks and, take in all the sights and sounds and just the pure in-depth nature that you're in back there. And, to find like we both have our heart in the right place for these projects, it really connects you to the resource a bit more. And Ryan, he's always been out in the Western New York region with me doing site visits and really forming those local connections. And something I'll reiterate a lot through this talk is this funding, it ultimately provides monitoring, but it also provided time, like time in the watershed to start forming like deeper relationships with our partners, the local DPWs. And in that time, you start to gain trust and then more connections. So next slide. Pass it off to Jared.
There we go. So thank you, Kyle. I will mention too that Ryan and Emily are both also WRI employees that are kind of housed in regional DEC offices, and they have quite a big region that they cover. They definitely get a lot of things done. So my name is Jared Popoli. I also work for WRI as a restoration hydrologist, working on all things culverts, assessment, mapping, coming up with tools and data and information for municipalities. So a lot of the work that kind of Kyle works on Trout Unlimited and the Nature Conservancy, as well as the majority of my work, is focused on road stream crossings and culverts and bridges. So a lot of times those culverts and bridges act as a barrier for trout and other aquatic organisms to go upstream and downstream, and they can be just as detrimental to that passage as a dam. So I'm going to talk to you guys about a national program now, NAACC, the National Aquatic Connectivity Collaborative. It's just kind of gone through some updates and changes, but it began in 2015, actually in the Northeast. It used to be called the Northeast Aquatic Regional or Aquatic Connectivity Collaborative, but it's now changing to a national program. Started in 2015 after Hurricanes Lee and Irene came in through the region and absolutely decimated our streams and waterways. And kind of the main folks who kind of took lead of it was UMass. They developed a protocol for teaching people how to go out and assess road stream crossings. So whether it's like take the inlet height, outlet height, width, all that information, it all gets uploaded into an online database. And they also have kind of a scaffolding and a training program to get people kind of certified to take this data. And from there, it's really grown. So it all started in the Northeast. It's expanded into the Southeast. And now it's turning into this national program. So the information gleaned from this project and program and data collected in the field then feeds a whole bunch of other prioritization efforts, mapping and information for municipalities. For the next one. So like I mentioned, NAACC, the National Aquatic Connectivity Collaborative, there's their website there. They've made really great online tools and mappers and things that are really kind of easy to navigate. I would recommend folks go and take a look at that. And it also encompasses not just road stream crossings, but also dams and waterfalls as well. So they have different mappers for just the inventory or collecting the data. They've also kind of developed a whole bunch of prioritization and GIS and mapping information for prioritization. So take a look over there. Like I mentioned, there's some changes going on. So the old Northeast version, the gentleman who started that in 2015 is retiring this year. So it's turning into this National Aquatic Connectivity Collaborative, which is actually, it's really exciting. So I know that the folks that are developing that have even been contacted by Canada to help them develop a program and kind of a way to collect all the data and information. So they're really, one of the biggest gains from this is that the same information is collected all throughout, the Northeast, the US, and maybe even Canada now. So you can really kind of compare apples and apples throughout the whole states. Here's a little map. So a lot of the data that's collected just sits in a database, and like you have to understand how to either work with GIS or what the information means. So we've been working on developing some maps for municipalities, for county highway departments, for people such as Trout Unlimited, et cetera, to be able to digest the information that's in there. So some of the maps that we're working on a story map to kind of explain how the data is collected and what it means, maybe how it could be interpreted or used. So we made a couple maps for inventory and evaluation just to show which crossings have been or haven't been evaluated. Made another map on stream habitat. So NAACC, it scores, aquatic organism passage just from kind of the inputs, the culvert slope, height of the roadway, et cetera. And then we've also added in things such as the New York State DEC stream classifications, historical fish species present, Eastern brook trout joint venture watersheds to show watersheds with historical brook trout ranges. And then where I come into this is the hydrology and hydraulics. So the information collected from NAACC, put it into a model to estimate how much water passes through the culvert before it overtops the roadway or the culvert capacity. And then we also compare that against the watershed hydrology, or how much water makes it to that culvert for various storm events to then develop flood risk. And then there's another map for crossing parameters. So I've been piecing together and figuring out who owns each of the culverts. So say if you're working with the town of Ithaca, you can click on something and you should be able to see just the town of Ithaca crossings. And from all that, there's been a bunch of prioritization efforts, whether through NAACC, some other kind of regional programs, and Nature Conservancy. I know Kyle will talk about some of their prioritization stuff as well. All this information gets fed into different prioritizations to help prioritize replacing culverts that are kind of having the biggest impact on fragmenting these populations. Go ahead. And so as far as New York, there's a group called NAACC New York that's formed, I don't even know, probably 5 or 6 years ago. With DEC, the Nature Conservancy, New York State Water Resource Institute, and soil and water conservation folks, who are all doing NAACC assessments, but it kind of made sense to look at it from a state perspective rather than the whole Northeast. So the group meets once a month. It's open to folks that want to hear more information. We have people from DOT, all sorts of other watershed groups, et cetera, that all meet monthly to chat about all things culverts. So it's a hub for kind of learning about road stream crossing happenings or trainings or events or things that are going on, as well as kind of keep tabs on funding sources. And I know we're looking at doing some other additional, like U.S. Fish and Wildlife Service or U.S. Forest Service trainings for Stream Smart, stream simulation, as well as in New York to kind of train municipalities, et cetera. And we're also developing kind of a regional coordination model to kind of help more projects and crossings get replaced on the ground. Yeah.
Perfect. Jared, you mentioned the prioritization models that you use. Those tie in very closely to our prioritization matrix that we use. The main difference being that we are looking at number of culverts in our priority watersheds, and also regional survey information, and also local knowledge. They really kind of all come into play in order for us to settle on what we consider are our priority waters. Within TU, we have a separate prioritization matrix for determining our priority waters. And for the sake of this presentation, the two that we'll be focusing on in New York State will be the Black River and the Genesee River. So to start with the Black River. The Black River, it offered a very unique setting to really see restoration at a landscape scale. That we do have these self-sustaining populations of brook trout and miles of connected rivers. However, these are often segmented by multiple road stream crossings through wild forest corridors and wilderness areas. And to get an idea of where we're working in the Black River, our focus area is in the Moose River Plains, and we do have a 10-minute film. However, we will play the trailer part, and if we have time at the end, we'll play the entire film on our Moose River Plains reconnection project.
Awesome. Thank you, Kyle. I'm going to scramble real quick and hope that I can make this work as seamlessly as I hope it would. Let's see if I can do that. Pressure's on to get the audio right in this moment. Gosh, I hope I get it. Cool. All right. Hope that.
Everybody clear?
I'm pausing for just a second. Does audio work or not? Can you all hear audio?
I don't think I heard anything on that first second there, but Denise has her
Okay.
thumb up, so it might just be my computer.
I'm totally gonna let it fly because I don't want to waste everyone's time. It's 1 minute. Hopefully you'll see it. If not, you will get a beautiful idea of exactly what we're up to with DEC and TU up in the South Moose. So sorry, you know how these tech things go. Let me go ahead and hit play.
Everybody clear? Anybody? That's like 2.2 announced.
TU and DEC are in the Adirondacks today. We have our teams out and we're really trying to understand where the brook trout are within the South Branch Moose River watershed with the goal of reconnecting, restoring habitat for brook trout.
We're not only going to get this important work done, which is going to be sustainable for a very, very long time for generations to come. We're doing work here today to make sure that these fish can adapt in the future. The wisdom of those people that came before us that set the stage for all this. Our forefathers here in New York saw the value in the Adirondack Park. Thank God that they did that, because if they didn't, we wouldn't have this opportunity.
One organization or the other can't do all of the work. There's a lot to do. And to see a crew of TU and DEC folks coming out to sample fish, let's do this.
This is going to be the ordinary here for the next few years in the Moose River Plains.
Cool. Back to it. Thank you. All right. Hopefully that works. Kyle, are we back on track? How's it look?
Yes, I believe we are back on track.
And thank you everyone for bearing with that. And Emily, thank you for dropping in the link as well. If time allows, we certainly are capable of going in and play on the rest of it, but that's the short trailer. And if you don't get a chance, please go watch on YouTube. Give us a thumbs up and a positive comment if you enjoyed the video. So thank you.
So as we all seen in that video, it kind of showed a snippet of what our survey techniques were in the watershed. Our main focus on year one of our funding was culvert assessments. So utilizing the NAACC protocol that Jared shared earlier to survey each one of the culverts in the Moose River Plains and then ultimately give it a score based on its passability index. We also carried out electrofishing above and below each culvert crossing to assess fish communities. And we've also installed an extensive array of temperature hobo monitoring temperature probes across the watershed to get an idea of current condition and then yearly condition for the 3 years that we've been in the watershed now. As we mentioned, all of those culvert assessments, they were done by our seasonal staff. So that is an example of what a field season could look like for a seasonal worker of ours. It's a great time out there. If you like no service, it's even better. As I mentioned before, we had our 17 survey locations, and by and large, what we found from our temperature data is that our 30-day average max temperatures, which is the hottest possible conditions averaged over the 30 days. So the hottest temperature of each day for 30 days is giving us ultimately the worst case scenario. With that being said, all of our temperatures in our brook trout priority sections were under 64 degrees Fahrenheit throughout the summer. So that shows a cold but also resilient watershed if there are fish throughout the season that do need to move into these cold water patches. Overall, we assessed 59 aquatic barriers, and after doing our analysis, we are looking to remove all 59 of those barriers, and that will open up 43 miles of habitat in the South Moose Basin. Here's just another example of what we would find quite common in all of our fisheries assessments, as well as what we find quite common, unfortunately, in all of our culvert assessments. There were a wide range of perched culverts, undercut culverts, culverts that provided a significant barrier to a lot of this fish movement. And brook trout are a species of fish that are known to move. It's proven in the literature, and they will move up to 12 miles a season if they're allowed to. However, if they're stopped by barriers like this, it would drastically reduce their ability to move, especially with our ensuing climate issues that we're having, especially with the main stem of the South Moose River heating up considerably compared to the tributaries. Sorry, next. So we kind of wanted to do a two-prong approach with our fisheries work, and we partnered with another organization called Trout Power, and their staple survey technique is looking at genetics. So are there any genetic differences between populations of brook trout within the same watershed, and if there's any genetic differences between brook trout above and below the barriers that we are looking to replace. So this is a very unique opportunity to look at genetics on a landscape scale and at an individual fish scale. We went out with a group of volunteers. I believe there were 23 to I think 30, and with DEC Region 5, we were able to create a survey sampling location map where we sent some groups out 6 to 8 miles into the wilderness with no trails in order to collect these fish samples. And this group of volunteers was very willing to get the job done. Overall, we collected 200 fish, and we were able to collect genetic samples from 195 of them. So it was a very successful effort. And here, next slide. Here we're able to see the individual fish results. So the text may be a little bit small in the legend here, but if we see the assortment of purple, green, blue, and red dots, those are all fish caught from a specific section of stream that we told them to sample. So overall, what we can see from this picture is a general watershed coverage. And since we have each fish geolocated, we'll be able to actually go back, identify fish again in 2 years after another electrofishing result, and use the imagery to collect potential recaptures. So we'll be able to see movement using imagery, but also movement within the gene pool of the whole South Branch watershed. So this ties in very well with our aspirations for culvert removals in the South Moose Basin. We have our strategy broken down into phases, and within the Moose River Plains complex, there is a series of roads that bisect the wild forest and wilderness corridors. So logistically, we are tackling those first. So those are considered intensive use corridors. There's also a number of trails that cut through, especially the Little Moose Wilderness area, and those are littered. When I mean littered, there's like 137 culverts with highly perched structures within these trail systems. And what we've been finding is a lot of these culverts can be removed and not replaced. So we would ultimately be regaining habitat without having to put more structures into wild forest and wilderness corridors. Next slide. As I alluded to a little bit before, there are multiple different forest classifications. We are working with the APA in order to handle all the permitting for these corridor areas correctly. So intensive use requires the least amount of permissions. Wild forest is the second most. And then wilderness, we are no longer able to use machinery. All of our work will have to be hand implementation. And we don't deal with primitive or canoe areas, but throughout the Adirondack Park, there are multiple areas that are primitive and canoe that we will take into consideration as we're using the South Branch Moose Project as a model for future work in the Adirondacks. Here are a few examples of what we run into out in the Moose River Plains. These are structures that are on some of the intensive use corridors, and some of these were also on trails. Believe it or not, brook trout are very resilient, and we did find brook trout above and below each one of these barriers. So seasonally, they may not prove to be a barrier, but during the most stressful times of year, these could stop the movement of brook trout specifically. From a safety standpoint, a lot of these crossings are in a very poor condition and, could cause harm if they're not taken care of properly in the next 10 years. Next one. So jumping from the, oh, Jesse, did we skip a slide?
It's possible.
Oh, there we go.
Sorry.
All good. So jumping from the Adirondacks now back to the Western New York portion, we have our focus on the upper Genesee River. And right off the bat, we can see many different landscape differences. We lose our topography. We have much lower gradient systems, lower energy systems that prompt multiple other hurdles that need to be overcome when working in these flatter areas. Next slide. Within the Genesee River, we have a priority focal watershed called Wiskoy Creek. It is a wild quality classified trout stream, and multiple tributaries of it have brook trout strongholds, according to the Eastern Brook Trout portfolio data. Looking at from an aerial perspective, one thing that I noticed immediately was the flatness, but also the linear nature of all of our culvert crossings. So you can basically see them laid out like a lattice framework because of all the flat agricultural land that kind of makes up the boundaries of these watersheds. We're dealing with highly groundwater dependent systems. So there is ample groundwater, very low gradient Spring Creek type watershed. And it's really just a complete opposite from working in the Adirondacks. What we found in this watershed is, even though it's flat, there are still a lot of barriers. And There were multiple within brook trout patches that, if replaced, would provide a significant amount of reconnection to upstream wetland habitat that our brook trout over here favor. Just to backpedal one step, we choose the Wiskoy Creek watershed by recommendation of Region 9 DEC fisheries staff. And that was a great call. We have a great working relationship with them. And it really opened the doors to brook trout work in Western New York.
Whoops. Sorry, guys. My fault. Everything was going so well there. We're back on.
Great. This culvert here was our number one priority. It's on a tributary of Trout Brook, and it was a severe barrier. There were brook trout above and below the crossing. However, there were significant structural concerns about this crossing, and we submitted it for WQIP funding, leveraged from WRI funding, and we were able to secure that funding. So summer of 2027, we will be removing and replacing this crossing and adding additional habitat above and below. As part of WRI, as I mentioned before, it really gives time in the watershed, and the relationships that we were able to build through this time has really took off in the form of workforce development. There is a local BOCES school, so it's a career and technical school that focuses on heavy equipment and construction and aquatic restoration. So I was able to meet some of the faculty and start to work with them slowly to build up a good skill set within the students, but also rebuild the curriculum. So now we have multiple labs that the students carry out both in the field and in the classroom that directly relate to aquatic conservation, but also habitat restoration implementation using heavy equipment. So overall, this was a huge win for our watershed. And honestly, the kids have a ball out there. They also help directly with some of our project implementation. They help stage materials. They have a wood mill where they use recycled ash to build stakes for projects like, Jesse, can you switch?
It's moving. There it is.
Conifer revetment projects. So these are simple process-based stream bank stabilization efforts where you line banks with parallel rows of Christmas trees and use the matrix of the branches to collect sediment and ultimately rebuild the bank over time. So what we see in that bottom left-hand picture is not what we'll see in 5 years. These projects are designed to decompose, and they are designed to look completely naturalized in 4 to 5 years. In 10 years, you'll never know there was a project.
Over time, we get the opportunity to plant over top of these, right? We've seen that as a proven success strategy is after the banks get rebuilt with these conifer projects. Not only they have fun upcycling, but they do allow us to go back in and re-improve the riparian zone with more shade canopy down the road. So yeah, these things work. We've had a project in Connecticut that's 6 years old now, and it's got 6 years worth of regrown conifers that have completely elevated and restarted a bank. So these projects work, and they make great habitat for trout.
Yeah, they hit the whole suite of community outreach, student engagement, free materials, and overall a very sustainable method of bank stabilization without using hardened materials like rock. On phase 2 of our WRI funding, we looked to branch out within the Genesee River, and my focus was primarily on brook trout resources that are imperiled. So I reached out to Region 9 DEC again, and we figured out a few watersheds that we should really target for more connectivity projects as well as habitat. So on the right side of our screen here and on the top left are a few examples of culvert assessments that our seasonal crews were doing in the Crider Creek watershed, which is the furthest south watershed in the Genesee River that's completely in New York State. And on the top left is an example of a brook trout from that watershed. So there's substantial growth. That's another thing we're actually looking at right now with the state is why do the fish get the size they achieve in that watershed? But there's also an ample supply of poorly constructed culverts. Next slide. So within the Crider watershed, we have many severe and significant barriers. There's more topography, so there's a higher gradient on a lot of our streams that really, with a lot of the extreme summer flood conditions we have, has eliminated culverts completely on their own or severely damaged existing culverts and made them completely impassable for all forms of aquatic life. So in the yellow, sorry, Jesse. In the yellow, we have our brook trout priorities, and these were found in combination of U.S. Fish and Wildlife and Region 9 fisheries staff. Next.
Sorry, Kyle.
So another positive from the WRI funding is that it allowed us to collaborate with other agencies who also have the same mission, and that is to primarily advocate for brook trout habitat and connectivity concerns. So I was lucky enough to forge a relationship with the Lower Great Lakes Fish and Wildlife staff. I've been in communication with them since I was in high school. So this provided the perfect opportunity to finally be able to partner with them and really use their team to accomplish some really novel work across New York State. Primarily what we've been doing, I started a cooperative agreement with Fish and Wildlife, and we were doing aerial thermal drone surveys on brook trout priority streams in order to help prioritize future restoration sites. We also collect hundreds of eDNA samples specifically looking for brook trout in waters they were not previously sampled in. And it really kind of opened the idea of future science collaboration and potential publications that we can get from the novel drone work that we're doing in these sub-watersheds. Next one. I've had multiple, different meetings and discussions with agencies across the state, and pretty much the jaws drop as soon as I bring the thermal imagery to the table when we're looking at planning for fisheries assessments, for placing locations of temperature loggers, but also analyzing road stream crossings. So as we can see here on the left is an ortho imagery, so color imagery taken at 300 feet, and on the right is the thermal imagery. And the bright white and bright yellow patches, those are indicators of groundwater influence. So you can see the ambient stream temperature is dark orange, and we have these large patches of groundwater that are entering the stream from multiple seeps. So it really allows us to see, especially if we fly upstream of a culvert crossing, the amount of groundwater resources we're able to also reconnect to the downstream. And with that, I would really like to say thank you to all of our project partners. Feels like we're just a big conservation family at the end of the day. And I know Jesse can agree with this. The world of conservation is a very small place. So, where you find where you want to work, you'll often, see friends who you went to school with years ago, also kind of succeeding in their own conservation space. Our partners have been amazing, and I just wanted to thank you for the opportunity with this WRI funding.